And welcome back to the second part of EIGRP. In this video we shall cover the configuration modes. So we'll be looking at classic and named mode. So basically the majority of your configuration will occur within the EIGRP process. Some of it will occur under the interface depending on what you are doing. So the main points occur under the command router EIGRP and then a number. Now this number is your autonomous system number, and all your devices need to be configured with the same AS number. You then follow this up with your network statements, which indicate which networks are participating in the routing process. And the command is network, the network address, followed by the optional IP mask. Now, if you don't use a mask, it will assume classful boundaries. So, for us old people out there that have been around for a while, will know them off by heart and know all the little ins and outs of that. Now, the problem with that is you can get a lot of extra networks being added in, which you may not actually want. The next mode is named, and again, it basically follows the same command structure for starting the routing process. Instead of putting a number in, you give it a name. So it's router EIGRP and the name of the process. Okay. It then changes from that point on. So all your configuration occurs within this EIGRP named mode. Supports all the current and future developments, and it supports multiple address families. So this becomes very useful when we are running VRF instances and we have multiples of those running. So it's relatively clear and easy to do once you've done it a few times. Now, the three main areas that occur under named mode are hierarchical in nature, and these subsections are address family, interface, and topology. So under the address family, you have your autonomous system, global commands. So this is selection of network interfaces, your K values that you're using, logging settings, and stub settings. Under the interface submode, these are your elements that apply to your interfaces, such as your hello intervals, split arrows, and authentication summary routes. More on that later. Topology is where the database is running and your algorithm and that are all there. So this is where that router information base is accessed, and it basically enables your route redistribution and administrative distance settings if you need to change them. So let's have a look at our network statements. So there's basically a very simple way of putting them in. They use a wildcard mask. Okay, so it's the router EIGRP and then AS number. In this example, we're using 1. And we're putting in the interface address and putting in quad zeros after it. So we're using a very explicit IP address in to identify the network and the interface. Now, as I said earlier, we don't need to be that specific. We can just put network 10.0.0.0, and that would include both our Ethernet 00 and 01, because they both belong to the class address of 10. Same goes down here. If you look at these two addresses, do they fall in the same category? And if you said yes, I think you need to go back and revise our 3 class 4 address ranges, because 192 is a class C, which means it's a /24. So 00, 10.0, they're 2 different class boundaries. Yes, I did that deliberately to trip you up. Okay, so let's go through the actual configuration example for our little topology down in the bottom left-hand corner. We have 2 routers and they share 1 network between them. They have a loopback interface each and 2 directly connected networks. So configure the interfaces as normal: IP address, subnet mask, rinse and repeat for all your directly connected networks. Then you go into router EIGRP 100 and then do your network statements. It's pretty good to use the rule of thumb of a network statement for each connected network. So that's your classic mode. In router 2, they've opted to go through the name mode configuration. So as you can see here, router EIGRP and then the name. And again, convention says for names we use uppercase. Then it's address family IPv4 unicast autonomous system 100, and then the network is a wildcard mask of any. So quad 0, quad 255s means it's not checking any bit, so they all match. And yes, they'll talk to each other because both of them are members of AS 100. Now for the show commands. So here we're using show IP EIGRP interface. Now this will give us a few bits and pieces of information. Basically, which interfaces are participating in our autonomous system. There are specific keywords there, and the one that says detail will give us a much more in-depth detail of each interface. So we can use the detail keyword in both modes. So if we can do interfaces detail, that will give us a detailed look of each and every interface. Or we can specify the individual interface that we want more detail on. So not only the standard information, we also get a little bit more information. okay, such as whether the authentication is on, what its timers are. So here's our hello timer, set to 5, hold down, it's 15. So what's it all mean? So looking back at our show command, the interface section tells us which interface this information is concerning. The peer is the number of detected peers on this interface. The XMTQ is telling us the number of packets that are reliable or unreliable that are in the queue for transmission. The 0 indicates a stable network. So that's what we're really looking for under this queue column. Mean SRTT, which is our average time to and from our neighbour. Next one is our multicast flow timer, which is over here, and this is the maximum time in seconds that multicast packets are sent. Pending routes are number of routes that are in the queue to transmit that haven't been transmitted out yet. So the adjacencies are critical to our entire topology. Alright, so we need to ensure that information is flowing to our neighbours and throughout the domain. So we need to keep track of our neighbours, because this is how we're going to know whether or not something's changed by monitoring that connection. So you need to have a neighbour relationship form, and your hello messages are going back and forth continuously to monitor that connection after you've formed your neighbourhood. And that happens when you're doing the convergence. So show IP EIGRP neighbours is the general command, and that'll give you all of them. You can specify a interface ID to get specific information about neighbours out of a specific interface. So again, coming through, we have the address of the neighbour, the interface that that neighbour can be found on, hold time. Now this is how much time's left before we call it dead. So if you've got standard timers, your hello packets are every 5 seconds, your hold time's 3 times that at 15. So this is telling us that 2 seconds ago it received a hello packet. SRTT is our messages sent to the neighbour and reply. Our RTO, timeout for retransmission. Okay, so in other words, it's waiting an acknowledgement. Queue count is how many packets are waiting in queue for sending. And then the sequence number is the last received sequence number on that neighbour. Now remember, when messages sent, they are tagged with a sequence number so that we can keep track of the messages. Within our routing table, our routes will be displayed with a D for EIGRP. Now, with this, our default administrative distance is 90. Okay, so we have an external EIGRP, which is AD of 170. Now, the external routes are basically the routes learnt from outside the protocol. So these are redistributed into EIGRP. Could be static, could be OSPF, or any other source of information. Alright, and the reason these have a higher administrative distance is to help eliminate loops. Okay, because if you have another routing protocol that has a destination of that network, it's probably more trustworthy than the routes being injected into EIGRP. So we'll use the other protocols before we use these external routes. And show IP route will give you all routes from all the protocols that's in the routing table. Or you can use the keywords for the protocols after that. So for EIGRP, that's its keyword. Now, just like OSPF, EIGRP does have a router ID and it uses a 32-bit binary number. So once again, just like an IPv4 address. And this is used to help prevent loops. Now, under our classical installations, we would not use these IDs, as it would take the highest IP address that is configured on the interfaces. So it's got the same behavior as OSPF. Looks for a loopback interface, if there's one, takes the highest active IP address from the loopbacks. If there's no loopbacks, takes the highest IP address from any active physical interface. Excuse me while I take a sip of coffee. IT and coffee goes hand in hand. Okay, so if you want to manually set this, we can do that under the routing process. So router EIGRP 100 and then EIGRP router ID and then the IP address in dotted decimal format. That will then become the router ID for the process, and it will identify where the information is coming from. If we're using named mode, we need to enter the same process again. So under the named and the address family, then we put in the router ID. Passive interfaces. Why would we want a passive interface? Well, if we don't expect another router to be active on that interface, so if it's our host machines that we would find out of that interface, we want to make that interface passive because we want to advertise the network so that traffic can be found to reach it. So it's active in the routing process, so other devices know this route exists, but we don't want to send route advertisements out of that interface because there's no router to send that information to. So we make it passive. So again, under the routing command process, you specify passive interface and the interface ID. Now, you can make that global and say passive interface default, which means any interfaces that are currently participating in the process will now shut down the routing process on that interface. And then you have to enter a no passive interface command for each interface that you want to activate again. Now, in most devices, it'll be easier for you to specify the one or two interfaces that you want passive rather than the other way around, depending on how many interfaces you have on your device. So how do you do that in main mode? It's a little bit more process orientated. So we have to enter our process, and now we're going AF-interface and specifying the interface that we want to configure, and then what we want to configure on that interface. So AF interface, gigabit 02, passive interface. So if we want to make it the default, AF interface, default, passive interface. We then need to go to the individual AF interfaces that we want to make non-passive. So it's a little different, and we can check what's going on with this with using show IP protocols. Will give us information about the protocols that are active on this device. So if we have more than one, you're going to get it all coming up. The next section is on authentication. Now, where we've got multiple access networks, where we can have more than one active device participating in the neighbor relationships, but we want to ensure that only the ones that are authenticated get the updates. So this is a way of controlling who can see our updates. So all the devices need to be configured with the same authentication method, keychain, and with the key string passwords. So this is going to basically log each other in. So you configure it on router 1, configure it on router 2, and they need to have the same passwords to authenticate with each other. So it's pretty much like a pre-shared key for authentication, like you would do on a VPN. So let's go through the process. So first step is creating that keychain. So the command in global config is keychain and then give it a name. Then you configure the keychain with a number. So this is saying key 2. Okay, let's go step by step. So keychain, EIGRP key, key 2, key string Cisco, and then you go into your interface and tell it to start authentication. So IP authentication mode EIGRP, followed by the autonomous system number and the mode that you're going to use, so MD5. IP authentication keychain, and then again tell it which protocol you want to apply the keychain to, EIGRP 100, and then the name of the keychain. Now, under named configuration, you set up the keychain the same way. Then you go into your interface that you want to configure. So, AF interface. Now, if you're using the same keychain throughout all your neighbors throughout the entire network, makes sense to make it as the default. And then authentication mode MD5, authentication keychain, and then the name. So there's a couple more steps to take, but then when you get into the actual authentication, there's less for you to type in, because it knows precisely which protocol and an autonomous system number. So pluses and minuses for each way. How can you verify that the keychain is configured? By show keychain command, and this will give you the names of each chain and what keys are configured under the chain, and then it'll tell you what the lifetime for each key is. You can have multiple keys and multiple times that the keys are valid on, but the default is always. Now, if you go back to that show IP EIGRP interface detail command, we will now see under authentication that it's using MD5 and which keychain it is using. So I thank you for joining for part 2, and I look forward to seeing you in part 3. Till then, goodbye.